Welcome to Click My Project.
Our project title is Efficient and Anomalous Mobile User Authentication Protocol using Self-Certified Public Key Cryptography for Multi-Server Architectures.
Let us see the abstract of our project. With the advance of a computer community and the widespread of dissemination of the network applications, users generally need multiple servers to provide different services. Accordingly, the multi-server architecture has been prevalent and designing a secure and efficient remote users authentication under a multi-server architecture becomes a non-trivial challenge. In last decades, various remote user authentication protocols have been put forward to a corresponding to the multi-server scenario requirement. However, the scenarios suffer from the certain security problems or their customers' consumptions exceeded users' own constrained ability. In this project, we presented an anomaly remote users authentication with a key aggregation scheme for multi-server architecture employing a self-certificate public key without a pairing. The proposed scheme cannot only retrieve previous schemes advantages but also achieving a user privacy concern. Moreover, our proposal can gain a higher efficiency by removing the pairing operation compared with the related scheme. Though analyzing the comparison with the related schemes, we can say that our proposal is with a scenario requirement and feasible to the multi-server architecture. A mobile user should be authentication and authorized to become crossing these multiple servers. Generally, the mobile user's authentication is method which is used validating a mobile login users. In this process, we proposing an anomalous mobile user authentication, that is AMA protocol, which yield better efficiency and security for the multi-server architecture using the SCPKC. The security analysis of our AMA protocol demonstrating that satisfying a security requirement in practical applications and it's previously secured in novel security model. By maintaining the security at various level, our AMA protocol is more practical for various mobile applications. Let us see the flow of our project. First one is a network model or a network formation. The node deployment is the first module of the project. The mobile nodes are to be deployed. The nodes are formed with a given range of the sensors. The nodes are grouped automatically depends upon their radio waves. Agents are formed for a group registration. This simulation is done in NS2. In that simulation model, there are 25 nodes are deployed in 1070 cross 1070 meters square field. All the nodes are set as a static nodes. The servers nodes are deployed in static wise. Here I deployed 3 server nodes. Then the next second one is a AMA protocol. Here the AMA protocol modules proposing of our anomalous mobile user authentication protocol. The protocol is implemented here. The proposed AMA protocol consists of 5 phases. First one is the setup phase, next user registration phase, then server registration phase, then mutual authentication phase and password change phase. Next one is a security phase. The security phase containing we analyzing the security of the proposed AMA protocol for a multi-server architecture. The encryption-decryption is done by an RSA algorithm. The RSA encryption for encrypting the data packet and use the hash function for identifying the varying the length and the digital signature for scheme for an authentication. If the authentication is successful, then it sends the data packet through the reliable routing path. The aggregation cipher text without a decrypting of the cyber text. I hope authentication is done here. The next one is a transmission phase.
The user sends the data to the base station.
In our RSA scheme, each base station plays a role in verification. All the signatures received from the nodes in the aggregation. The base station check the security and then sends the destination or a server.
Next one is a performance evaluation. The performance analysis
Is containing the difference network parameter analysis is done for the proposed protocol. Parameters like throughput, packet delivery ratio, delay are calculated for the proposed scheme.
Let us see the output of our project. First, open the terminal window. Type cd space EAMUAP.
The EAMUAP folder containing our NS2 coding.
Now I run the main.tcl file. So I type ns space
main.tcl. Now run the project. The node ID and the certificate ID is generated for each node. If the node ID and the key value is matched means that is valid node, and mismatched means that is invalid node. The invalid node did not allow for any communication. Now run the
nam. So type nam.
This is NAM console. Go to the file and open. Then click the out.nam file. This is out.nam. Our output is this. Now I play the NAM window. Now server is start. The node ID and the certificate ID is generated. Each node have a node ID and the certificate ID. If the node ID and the certificate ID is matched means valid. The node ID and the certificate ID is mismatched means it is invalid. It is containing a server. Here I deployed a 3 server architecture because of a multi server architecture is in our project. This is server, this is second server, and now this is a third server. Now I explain the performance evaluation of our graph. So type xgraph space delay.xg. This coding is used to show the delay of our project. This is delay of our project.